Hello, this is Alexander Eckert, and I'm going to go over Assignment 5, Question 1. Okay, so the question is, we need to find a model for each of the following well-formed formulas, and those are these here. So, exists x for p of x implies for all x, p of x. And then we've got another one for all x, and then all bound in within that is p of x of f of x implies p of x comma y. Okay, so first question is, what is a model? Well, a model is an interpretation of a well-formed formula that is true. And only one interpretation is needed, so not every interpretation needs to be true. Alright, so for the first one, we've got this here, and we need to choose a domain. So we're going to let domain D be the set of A and B. And we're going to let P of A be false, and also let P of B be false. I find with implies problems, it can be really easy just to keep everything false, and then it ends up being true in the end. So to rewrite the formula that we've got here, we know that the domain is A or B. So for exists x, that's going to translate into or. So we know that P of A or P of B is going to need to be true. And then for all x, that's going to end up being translated as and. So the final formula you end up with is P of A or P of B, and then that implies P of A and P of B. Okay, so we just need to assign some truth values now. We already decided that P of A and P of B are both false, and that this is our formula. So it's real easy to plug them in. We know that everything's going to be false, so false or false implies false and false. And then that can be broken down as false implies false, which is true. And therefore this interpretation is true, and this is a model of the well-formed formula. For our next one, we again need to choose a domain. So again, I'm going to let domain D equal the set of A and B. And then I'm going to let all of the possible combinations for P be false. And then I'm going to let f of A equal B and f of B equal B as well. Alright, so we're going to rewrite the formula. Again, we've got our domain D equals A and B. And then this is our well-formed formula. So we know that when we get rid of the for all, that's going to break down kind of like this here. This is kind of the first step. But we've also still got this y variable that was not bound. So that could still be A or B. So if we rewrite this, this is if y was A, and then we can add, using that, if y was B. So then this is going to be the entire well-formed formula over the set AB. So now we've got this really long, complicated looking thing, but it's actually not that bad. Once we take our domain that we've already assigned, and we know that we've let everything be false, and f of A be B and f of B be B, we can then plug in, and the first thing I'm going to do is get rid of these f functions, and so we know that all those are just going to end up being B regardless of what gets plugged in. And so what we're left with is this. And then very conveniently, again, all of these are false. So false implies false and false implies false, so on and so forth, which gets simplified as true and true and true and true, which is true. And so we can say that this interpretation is indeed a model for the well-formed formula given. And that is my full explanation for this. If you have any questions, please let me know. I'll be in class and able to answer them.